Let's just dive right in, shall we? Today, we're tackling a huge challenge. How do we actually bridge that critical gap between these high-level compliance mandates and the deep, practical, technical implementation for enterprise AI? As a cloud solution architect, I see this all the time. Organizations are really struggling to move from abstract AI policies to actual boots-on-the-ground runtime security. So my goal today is to kind of be your guide through all this. We're going to walk through a forward-thinking blueprint that literally turns AI risk into manageable operational risk. To keep things actionable, we've structured this into 6 clear stages. We're going to look at the AI threat landscape, compliance governance, the Microsoft Cloud AI architecture, exact technical controls, implementation and fallback plans, and then finally, wrap it up with a summary for decision makers. And really, this all boils down to the fundamental question facing pretty much every CISO right now. How in the world do you safely deploy incredibly powerful tools like Microsoft 365 Copilot or your own custom AI agents without suddenly creating this massive, totally ungoverned attack surface? I mean, we all want the innovation, right? But nobody can afford the compliance nightmare that comes with it. So let's start with Section 1, the AI threat landscape, and why we need to look way beyond traditional AppSec. Look, if you've been in IT for more than 5 minutes, you know that the absolute second you deploy a new tool, somebody is going to test its limits, right? Usually by asking it to summarize some highly confidential document. And that's exactly why traditional application security just completely falls apart when we're dealing with large language models. The game has changed. If you think AI breaches are just some theoretical exercise, check this out. IBM's 2025 data shows that 13% of organizations have already suffered AI model or application breaches. And the really scary part? 97% of those compromised companies lacked proper AI access controls. Another 8%? They didn't even know if they'd been hit. This isn't just about patching an exploit anymore. It's a profound language layer manipulation problem at inference time. Now, take a look at how these theoretical OWASP vulnerabilities actually translate into runtime abuse. An attack today isn't just a bad line of malicious code. Instead, it's an indirect prompt injection hiding quietly in an email thread, or it's tool coercion, where an unsafe API call is disguised as just benign automation. This production reality means we absolutely must have robust controls. Things like real-time prompt firewalls, strict data fencing, and continuous artifact provenance checks to stop shadow models and IP erosion dead in their tracks. Moving right along to Section 2, compliance and security governance, and how we map this to actual frameworks. Security just can't exist in a vacuum anymore. It inherently has to prove compliance. And we absolutely cannot ignore these EU AI Act deadlines. This legislation entered into force in August 2024. Banned practices prohibited by February 2025. And by August 2026, those incredibly strict high-risk AI requirements kick in. Missing these timelines isn't just a slap on the wrist. We're talking potential penalties of up to 35 million euros or 7% of your global annual turnover. That is a massive hit. So how do we actually operationalize all that legalese? Well, we take the NIST AI risk management framework and translate it into continuous, measurable guardrails that will actually stand up to a rigorous audit. The core functions, govern, map, measure, and manage, they have to evolve from just being static paperwork exercises. We're talking real ownership workflows, mapped system boundaries, active red teaming, and playbooks that give you immediate containment and evidence preservation. Okay, Section 3. Let's look at the Microsoft Cloud AI architecture, which is essentially our zero trust blueprint. To actually execute on this zero trust strategy, we're leaning heavily into the Microsoft ecosystem. By utilizing Azure OpenAI service and integrating it with an Azure VNet and private endpoints, we achieve this vital, totally isolated network layer. What this means is that your sensitive enterprise prompts and your private data never, ever traverse the public internet. They're never used to train public foundation models. Period. Your AI environment essentially becomes this highly secure private extension of your own corporate network. And then, down at the data layer, Microsoft Purview is really the engine making this entire zero trust blueprint hum. It acts automatically to discover, label, and protect sensitive info across your entire unstructured data estate. And it does this before that data ever gets near the AI's reasoning engine. Basically, if the AI shouldn't see it, Purview makes sure it's cryptographically restricted or redacted. It's a real game changer. All right, let's get into the weeds a bit with Section 4, Technical Controls and Specs, where we define our 4 control planes. To safely deploy these AI agents, we have to establish 4 distinct, interacting control planes. The real foundational pieces are the identity and data planes. Microsoft Entra ID sits at the identity plane, enforcing conditional access, dictating exactly who can interact with prompts and which agents can even be invoked. Right alongside that, your data plane uses Purview DLP as this real-time prompt firewall. It's constantly inspecting inputs for sensitive information types, or SITs, and enforcing cryptographic masking, so PII is redacted before the LLM even knows it exists. And naturally, all of this gets logged into warm storage. That's write once, read many, so you have an immutable trail of compliance evidence. But we can't stop there. Simultaneously, your runtime and audit planes have to be constantly vigilant. You've got Defender for Cloud Apps catching behavioral anomalies at runtime, say a sudden weird spike in sensitive API calls. Then Microsoft Sentinel orchestrates all those interactions into one centralized audit ledger. And here's a crucial piece. SharePoint Advanced Management enforces strict content governance using restricted content discovery. This ensures that any sensitive prompts we happen to extract for forensic review don't just accidentally get re-ingested by Copilot's search index. Now for Section 5. Let's talk about implementation and fallback plans, the step-by-step execution for IT. For the IT implementers out there listening, I know high-level architecture is great, but it's not enough to actually build the thing. Let's look at how you set up these automated redaction gates in Purview. First, you target the specific Microsoft 365 Copilot location. Second, you define your custom sensitive information types, maybe internal project code names, things like that. Third, you map these directly to a hard block action. Restrict Copilot from processing content. And lastly, and I can't stress this enough for user adoption, always deploy in simulation mode first. You've got to tune out those false positives before you start enforcing hard blocks on your users. Next up, to automate the extraction of high-risk prompts and actually build a feedback loop for your AI governance committee, we orchestrate everything through Microsoft Sentinel. You're going to ingest those Purview audit logs straight into Sentinel, build a logic app that gets triggered by high-risk DLP alerts, and then use a least privileged managed identity to securely push that anomalous prompt metadata into a heavily restricted SharePoint list. Now, as an architect, I'll be the first to tell you systems fail. It happens. If your automation pipeline breaks down, maybe due to log streaming latency or API throttling in your logic app, IT has to be ready to pivot to a fallback strategy. You have to be ready to rely on manual Purview audit search exports, drop them into encrypted Azure Blob storage as a temporary holding pen, and run manual SharePoint permission state reports. Having this manual fallback is absolutely critical. It guarantees you maintain that continuous compliance even when the shiny automated stuff is having a bad day. Finally, Section 6. Let's summarize all this for the decision makers: business value and risk mitigation. So, why go through all this trouble? Why invest in this level of governance? Just look at the real-world ROI. Take the law firm Ballard Spire, for example. They deployed secure Azure AI to comb through their massive internal repositories. And the result? They cut non-billable research time by a staggering 60%. That's an estimated savings of $2 million. And the kicker is, because they used this exact secure architecture, they pulled this off while maintaining 100% strict client confidentiality and data isolation. Ultimately, this Microsoft-centric architecture isn't just an IT win. It provides genuine board-level security. It completely transforms those old, reactive point-in-time checks into a continuous lifecycle control plane. It establishes a highly documented presumption of conformity for the EU AI Act. It shuts down the creeping danger of shadow models and IP erosion, and most importantly, it lets your business safely and confidently scale AI productivity because you know the guardrails are verified and active. I think this quote on screen perfectly captures our entire philosophy today. AI security simply cannot be handled by a single, fragmented point tool. It's a lifecycle discipline. You have to treat AI risk with the exact same rigor as operational risk, and that means combining zero trust, continuous validation, runtime enforcement, and automated compliance evidence into one cohesive strategy. But please remember this: while all this automation is incredible, human oversight is still absolutely mandatory. The second a new external plugin or an autonomous agent gets enabled, your attack surface expands. The AI perimeter isn't some static wall anymore. It's constantly shifting and morphing based on what the business is trying to achieve. So, I'll leave you with this final thought to chew on. As your enterprise AI agents become more and more autonomous, capable of executing entire workflows on their own,
Is your security posture actually adapting at the speed of the machine, or are you still relying on the speed of a manual audit? Thanks for joining me on this explainer today. I highly encourage you to go review your own control planes against this blueprint as soon as you can.